As part of the 3D Analyst, ArcGlobe also provides the capability to put 3D models and 3D symbols into your global visualizations. This gives us the ability to create very photorealistic scenes using our geographic data. In this example, let's use ArcGlobe and take a close-up look at Honolulu, Hawaii and Waikiki Beach. Using ArcGlobe, I can navigate to a predefined bookmark for Waikiki. And you can see we can start to look at the high-resolution aerial photography, the terrain data for Waikiki and Diamond Head, and then we can start to display three-dimensional features. In this case, three-dimensional buildings that are objects stored in the geodatabase, each of which has attributes. For example, if you identify the Royal Hawaiian, you'll see all the attributes associated with this building. And each of these features also have textures. The textures provide the window patterns and the type of construction materials on the exterior of the buildings. We can also use data in our Geographic Information System database, for example the fire hydrant locations or the locations of all the trees, and place three-dimensional symbols at these locations. We can continue this analysis and add in more and more detailed information, for example locations of automobiles, traffic signals, and so forth, and we can interactively start to adjust this display and start to get a good view of what things really look like in this area. Now the important thing to consider is that it's not just about 3D visualization. For example, we can take any of our geographic data and start to overlay it on top of these visualizations. For example, if I wanted to combine the parcel-based land use map with this data, I can add this as a thematic layer on top of our photorealistic visualization. I could then come over here to a view from the beach of the Royal Hawaiian, and you can very clearly now see the land use information. Again, we could identify that parcel and look at all the attributes associated with that. We can take this analysis a little bit further. It's not just about visualizing the data, it's also about creating the data and doing analysis. For example, let's turn on this broadcast transmitter layer. In the center of our display you'll see a proposed new transmitter, and what we'd like to do is understand what's the signal strength of the radio waves propagating from that tower given all the buildings and the terrain of this area. In order to answer that question is a geoprocessing task, and as such we can use the model builder that's provided with the geoprocessing framework and look at a model that was written by the Department of Commerce to calculate the signal loss given a series of parameters for that radio tower. So using this model for signal loss, we can integrate that into a model builder workflow so that we can run this model. We can look at all the parameters associated with the proposed new radio tower and adjust those as needed, or simply accept those as the default and run the analysis. And now what it's doing is it's actually calculating, given the three-dimensional geometries of these buildings and the terrain, what kind of signal strength can we expect in and around the Waikiki area. This is important for many applications, one of which is homeland security and public safety. If you want to try to communicate to people in the field, first responders going into an emergency situation in this area, you'd like to be able to maintain radio communication with the people as they start to move around these buildings and enter the buildings. So this is the kind of analysis that we would do so we could start to calculate exactly what is the signal strength of that radio tower, and if it doesn't meet our needs, then we could go back and do a what-if analysis, run a series of alterations on this model, look at different parameters, and try to come up with a solution that makes the most sense. So as this model completes, what we will see is a thematic map draped on top of our three-dimensional model in our three-dimensional display, showing us the signal strength given that proposed tower. Green indicates a strong signal, and then diminishing signal in yellow, and then orange. And finally, if we were to look at the results inside the building for the Royal Hawaiian, red indicates a loss of signals totally, so we've actually lost communication in these areas if people were to enter the building. So this is a nice example of how we start to use the three-dimensional visualization environment, but it's really more than just visualization. It integrates all the analytical capabilities of a geographic information system.